Okay, just like with sines, cosine ratios also work for non-right triangles. We just have to adjust it a little bit. So, with this triangle below, note that this side over here on the right would be lowercase a. The side along the bottom would be lowercase b. And the side along the left would be lowercase c. Right, they correspond with the opposite angle and they're just lowercase letters. So here's the law of cosines. And forgive me as I feverishly try to color code this. A squared equals b squared plus c squared. That looks a lot like the Pythagorean theorem, doesn't it? But there's more. This law of cosines is actually an adjustment of the Pythagorean theorem. So a squared equals b squared plus c squared minus 2bc 2bc times the cosine of a. This minus bc cosine of a is what allows us to adjust the Pythagorean theorem to use it for any non-right triangle. Now, for some reason, a lot of the time whenever you learn about law of cosines, they give you three formulas. This is the only formula I feel like you need, but I want you to be prepared for the fact that most of the time you're going to see three different versions of the same thing. B squared equals a squared plus c squared minus 2ac times the cosine of angle B. So you'll see that the side over here, squared, is the thing I'm taking the cosine of, right? The side I take the cosine of the opposite angle. And similarly, c squared equals a squared plus b squared minus 2 times ab times the cosine of angle C. Okay, so if that has overwhelmed you, I'm sorry. But this is really not going to be that bad, okay? Ugly is all sin. Get it, sin sign. Ugly is all cos, I guess. But we can do this, okay? The first question I have down here. You have a side length of 14, a side length of 19. The included angle, that's just a fancy way of saying, hey, the angle between the two sides we know. And we want to know the third side of the triangle. Now if you want, you can label these angles A, B, and C. Sometimes that helps. It doesn't really matter what you label them, so long as you label them and keep up with what you've done. Okay? And so I would be solving for little a. Okay? So, little a is x here. So I'm going to use this version of my law of cosines. You ready? We're going to say, let me get a different colored pen here, there we go. We're going to say x squared equals the other two sides squared. It does not matter what order you write them in. 14 squared plus 19 squared minus 2 times those same two numbers minus 2 times 14 times 19 times the cosine of angle A. So you're definitely going to work with this angle opposite the side that you're solving for. times the cosine of 77 degrees. Okay? Now, all of that evaluates to a number. I want x, not x squared. After you set all of this up, believe it or not, there is one step to getting my answer. And that one single step is take the square root of both sides of your equation. The square root of x squared and the square root of 14 squared plus 19 squared minus 2 times 14 times 19 times the cosine of 77. And what you can do is just type all of that into your calculator at once. Okay? So, first, let's do a good old vibe check on our calculator and make sure that our mode is in degree mode. Otherwise, we're going to get messed up here because we're working with degree angle measures. So, I took the square root of x squared, that is x. All of this is going to give me an approximately equal to number. Then, second, square root of 14 squared plus 19 squared minus 2 parentheses 14 parentheses 19. Cosine 77, close your parentheses. Just double check as you type that in. Just, ooh, am I typing in the right stuff? If you have to, just scroll back through just to make sure and then hit enter. That's your answer, 20.91. That side length is approximately 20.91 units long. I mean, wasn't that so easy? The hardest part is setting it up. That really and truly is the hardest part. Okay, let's try a different version of these types of problems that still involves the law of cosines. With this triangle, I have all three sides, and I'm looking for an angle. So, what I'm going to need to do is set up the law of cosines, and then do a little bit of grunt work to solve for that angle. So, let's go ahead and just label these. A and little case a, and we can just call the other ones B and C. Where are my other two colors? There they are. Okay, so a squared, little a squared, 57 squared equals little b squared, so 40 squared, plus c squared, little c, so 36 squared, minus 2 times little b times little c. Little b is 40, little c is 36, times the cosine of what I'm solving for, right? Times the cosine of the angle across from A. So this will just be times the cosine of theta. My ultimate goal here is to get theta by itself. So all of this stuff, the 40, the 36, the 2, 40, 36, and cosine have got to go. Now, there's a couple of steps, and I'm going to physically write them out. My first step here is to do 57 squared minus 40 squared minus 36 squared. Basically what I'm doing here is making a flowchart. I'm subtracting 40 squared and 36 squared from both sides. That will cancel them out on the right side of this equation and just simplify the left side. So 57 squared minus 40 squared minus 36 squared. Figure all that out. 57 squared minus 40 squared minus 36 squared. Now you could totally square all those numbers first, but it's going to be a big, hideous number. Okay? This just gives me 353. So 57 squared minus 40 squared minus 36 squared, that all cancels out. I get left with 353 equals negative 2 times 40 times 36 times the cosine of theta. So all of this canceled out by subtracting them from 57 squared. Now I'm going to multiply all this out. To get negative 2 times 40 times 36 to get negative 2880. So 353 equals negative 2880 cosine of theta. Now, I got to get the cosine by itself before I can get rid of the cosine. To do that, I'm going to have to divide both sides by 2880. Negative 2880, excuse me. On the right side of my equation, that will just leave me with the cosine of theta. Now on the left side, this 353 divided by negative 2880. If you type that into your calculator, you're probably going to get a really ugly, irrational, not really irrational number, but a really ugly number. It is rational, actually, because it is a fraction. It can be written as a fraction, right? And as a matter of fact, if I rounded this right here to like negative 0.12, I would get the question wrong. The biggest, most important thing here, leave this fraction alone. So whenever I divide both sides by negative 2880, I get the fraction negative 353 over 2880. Leave the fraction alone. Don't round. You don't want to round until the very end. At the very end you can round, but not midway through the problem and then keep working off of that estimation. Okay? Now, I want theta, not the cosine of theta. To get theta by itself, go ahead and just take the inverse cosine of this. So theta equals the inverse cosine of negative 353 over 2880. Again, I know it's super ugly, but this is the exact answer, okay? Then just type that in your calculator. Make sure you're in degree mode. Second cosine of negative 353 over 2880. You get that that is approximately a 97.04 degree angle. That brings up a good point. That doesn't look like a 97 degree angle, so the figure's not drawn to scale. You should just get used to that, okay? Number 3, it's words, no picture. Triangle ABC has side lengths 20, 30, and 40. Find the measure of angle B. That says the measure of angle B. Well, first off, they didn't give me a triangle, but they gave me some information about a triangle. I know what a triangle looks like, roughly, so just draw one. Let's see, we've got triangle ABC. Well, I'll call that A, I'll call that B, and I'll call this C. Didn't matter which ones you called it. Now, if this is A, then this must be 20. If this is B, then 30 must be on the bottom. And if this is angle C, then this side must be 40. And I'm trying to find the measure of angle B. That would be this angle right here, which I'll call theta. So, you start with the side across from the angle you're solving for. 30 squared equals the other two sides, 40 and 20 squared, minus 2 times these same two numbers again, times the cosine of theta. This is a lot like our previous question where we've got to do a lot of work. But it kind of does just boil down to two steps. My first step is to subtract this from both sides. So 30 squared minus 40 squared minus 20 squared. You'll notice I got a negative number there. That's okay, that can happen. Negative 1,100 equals. I'm also going to multiply all this together, including that negative. Just because negative 2 times 40 times 20 is kind of ugly, you know? So, negative 2 times 40 times 20 gives me negative 1,600. Times the cosine of theta. Just carry that cosine on down. Okay, so that was kind of 2 steps. It's only one step in my line, but I had to do two things. My next step is divide both sides by this number, whatever's the coefficient on cosine. Now you may notice I'm dividing a negative by a negative. The answer will be a positive. Now you can leave this, because this one has some nice pretty numbers actually, you can leave this as 1100 over 1600, but that will simplify to 11 over 16 if you want, okay? Negative 1100 divided by negative 1600. It gives you actually a decent enough decimal. You could use that decimal so long as you didn't round. So like here we had to keep this ugly 353 over 2880. Here we could just use all 4 decimal places. Okay, decimals are allowed, you just don't want to round them off. If I said that was 0.7, I've just shot my answer. Okay, so I'm just going to use the simplified fraction 11 over 16 equals the cosine of theta. I want theta, so switch that and give me the inverse cosine of 11 over 16. And then I'll type that in. The inverse cosine of 11 over 16 is about 46.57. So angle B is about 46.57 degrees. I just want to say, if I'd used the decimal, the inverse cosine of 0.6875, I will get the exact same answer, okay? If I had done the inverse cosine of 1100 over 1600, same thing. So, as long as you do not round that fraction off, you're fine, okay? I got one more example in this video, and of course it's a word problem. So we got Adam, and he is putting a golf ball at a distance of 38 feet from the hole. So let me just go ahead and draw Adam. And let me draw, it sort of looks like a music note to me. Adam is putting, and he is 38 feet from the hole. So that would be 38 feet. But Adam messes up and hits his ball 22 degrees off course, and it rolls 40 feet. So this is a 22-degree angle, and it rolled 40 feet. And then his ball lands right here. How far is the ball from the hole on Adam's next putt? So we want to know this distance. Okay? With this, I can definitely use the law of cosines, and it's the easy part where I'm just solving for a side length. So, let's go ahead and just, ignore kind of the picture a little bit and just make a nice pretty triangle out of this. I will call from where Adam started angle A, and this side over here, lowercase a. I'll call the whole, I'll call it h, or, I'll just call it b. And this side, lowercase b. I'll call, I should have put b where the ball is, because b for ball, right? And I will say capital C for where the ball is, and lowercase c up there. But the letters really don't matter, okay? Now, we're solving for that, so a squared equals b squared, lowercase b, plus c squared, lowercase c, minus 2 times times b times c. So 2 times 40 times 30. 38. Excuse me, 38, my goodness. Times the cosine of 22 degrees. Now if you remember, I'm solving for this side length. Now I could have called it A or X or D for distance of the ball or whatever. Okay, it's just a placeholder. If you remember with this type of problem before, all I gotta do is take the square root of both sides. So let me just take a square root of a squared and a square root of all of that. So a is approximately, and then type in the square root of all of that very, very carefully into your calculator. Square root of 40 squared plus 38 squared minus 2 times 40 times 38 times the cosine of 22. Make sure that was all under that square root. You hit enter and you get 15.01. So A is about 15.01, almost exactly 15 feet from the hole. Okay, that's all I've got for you. Thank you so much for watching. Try those practice problems. Let me know if you need any help. Thanks. Bye.